This question is very typical of an exam type question because again, getting you to ask the draw the diagrams up because once they start doing that, they can start asking about areas because we can see there's areas between curves, areas under curves. So draw them up carefully. Sin x, cos x. So sin x, we know what that looks like, and cos x starts at 1 from 0 and then goes through and finishes back at pi and 2 pi as well. So the first one I want you to do is find the coordinates of the points of intersection. So we want to find, well, where is it intersecting there, when it's intersecting there. From our graph, if we're drawing the graph up, we should try and know that it's pi on 4 and 5 pi on 4. To prove it, let them be equal. Like, that's how we solve uh, equations simultaneously. We make them equal to each other. Sin x equals cos x, divide by cos x, tan of x is equal to 1. So should give us pi on 4 and 5 pi on 4. Tan's positive in the first and third quadrants. And when that's the case, we get it minus 1, positive 1 on root 2 in the first quadrant, negative 1 on 2 in the second quadrant. So there's our points of intersection. And that leads us to the next one, is like find the area between the curves, bounded by the curves, and the x-axis. So when we look at that, then find the area bounded by the curve sin x, cos x. So we're looking there and there. So again, oh sorry, it's only between pi and 2. I was going a little bit further. So if we look at that there, really what we're looking at is the area under sine of x between 0 and pi and 4, and then pi and 4 to pi and 2. It would be under cos of x. This, you can see, like, just looking at that one, it's going to be the same area if we had to find it there. And again, you've seen the nice symmetry of the curves. So no matter where we're at with all these curves, then you'll be able to find the area. Like, there was a HSC question a few years ago where it had find the area between these 2 points. So it's you use the symmetry to your advantage in a lot of these questions. Again, you could look at this one and say, I'm going to get the same value each time. So it's working out this. If you used it as 2 lots of this equation, this expression, you would get the same answer. So, but I've done it between 0 and pi and 4. Again, integrating sin x, integrating cos x there between the values, so 0 to pi and 4, and pi and 4 to pi and 2, and do the substitution. You can see you get 2 lots of the same values. So those two are going to be exactly the same if you can notice the symmetry between them. But again, just be careful with your integration, careful with your substitutions, getting the right values, and then being able to simplify, because we start to do with the 1 on root 2 and everything. So just be careful there. But if you can notice the symmetry, it may make life easier when you're doing some integration and area questions.